Assalamualaikum and good day to everyone. So today I'm going to continue chapter 5 on flip-flops. Alright, so maybe some of you already know what is flip-flop, but for those who never heard about flip-flop, we will learn on this chapter. So this chapter have 7 subtopic that we will cover. So for this video, I will cover on 2 subtopic, NaN and NOR latches, and then gated latch. Alright, so before we go to latch and what is flip-flop, we first need to know what is sequential circuit and what is the difference of sequential circuit compared to combinational logic circuit. So previously in chapter 4, you already learned how to design combinational logic circuit and how combinational circuit can implemented to be a function logic. So what is combinational logic circuit? So combinational logic circuit, which the output only respond accordingly to the present input. So means that the output only can change depends on the present input. When input change, the output will change based on the input that pass through the combinational circuit. Alright, but for sequential circuit, the output will depends on present input and past input value. So from this figure, you can see this is combinational logic circuit and this one is sequential circuit. So combinational logic circuit, you can see there's input and output. So the output depends on the input that come inside the logic circuit. But for sequential circuit, the output depends on input and also from the previous input. Okay? So sequential logic circuit, you can see here, depends not only on their current input but also on their past input. So we call this one as memory. They have memory, means that they can remember what is the previous input. Alright, so we have 2 types of sequential logic circuit. We have latch and we also have flip-flop. Okay, latch and we have flip-flop. So latch, remember 1 bit, so either 0 state or the 1 state, and the appropriate input can change its state at any time. It can change the state at any time when the input are changed. And flip-flop also have 0 state and 1 state, but it can change its state only when there is appropriate input and clock signal. Means that even the input are changed, but without clock signal, the output won't be changed. So flip-flop need a clock signal to change the state of the output. Alright, so we will move to the 2 type of latch. We have NaN latch and we have NOR latch. NaN latch means that the latch are formed from the NaN gate. So you can see here, this is NaN gate. So NaN latch, or we call also SR latch, NaN gate SR latch. Okay, it consists of 2 interconnected NaN gate. So we have 2 input. We have S, we have C. S is set, C is clear or reset. Like a switch, we have switch that can set or on the switch, or we have switch that can off the switch. So there's 2 input, set and reset. Reset, or also we sometimes call it as clear. So we have 2 output, Q and Q bar, which Q is the output, Q bar is the complement or invert from the Q. Alright, so this is the truth table for the NAND latch, NAND SR latch. So we have SC input, we have Q before and Q after. So you can see here, if we give the input for the S and C is 0, 0. So if the Q before is 0, 1, the output will become 1, 1. So it is impossible to have Q and Q bar have the same value, because Q bar is the complement or invert from the Q. So supposedly, if Q is 1, Q bar should be 0. But in this case, when we give the input FC is 0, 0, the output will become 1, 1. So this one, we call it as invalid, because the output is invalid because both our output will get both 1. When we give the input SC 0, 1, we get 1, 0 as the output. And this one, you can see Q is 1. So we call it as set. If we give the input SC is 1, 0, we get the output 0. So we call it as clear. And if you see here, when we give the input of SC is 1, 1, what happened? If the previous Q is 0, 1, the output after is 0, 1 also. If we give 1, 1, the Q before is 1, 0, the output also will get 1, 0. So means that it will hold the previous output. Means that it unchanged or remain unchanged. Hold the output from the previous input. Alright. So the truth table of NAND latch, we can see here 0, 0 will become invalid, 0, 1 set, 1, 0 clear, 1, 1 hold. So why we call it this one as active low? Because 0, 1 means that we activate the set. That's why we get set. But we activate using 0. So we know that active low input means that we activate the input when it is 0. And this one you can see here, we activate the C. That's why the output become clear. So we call it as SR latch from the NAND gate is active low input. So this is the logic symbol for NAND latch. Alright. Okay. Okay. So, alright. So you can see here, NAND latch is active low input. Alright. So because we have bubble here, means that it is active low. So how to get the timing diagram? So you can see here, the first one, S1, C is 1. So it's supposed to be 0. Alright, 0, 1. It will get 1 set. 1, 1. Okay, 1, 1. It become whole. 1, 0 is supposed to get clear. That's why we get clear. 1, 1, we get whole. 1, 1, whole again. Means that we remain or unchanged. 0, 1, we set. 0, 1, set. 1, 1, whole. 1, 1, whole. 1, 0, we get clear. 1, 1, whole. So, you can see here, the Q is responding to every input changes of SC. We also call latch as level sensitive. So every time the input are changed, it will change the output. Alright. So let's say we want to sketch the output of Q from the NAND SC SR latch. So the first thing that you need to do is you need to draw the vertical line at every input transition. Transition of each input. Changes of the input. So you can see here, changes here, 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 here. And then the next step, you need to write the value between the lines. And usually we have initial value of Q usually they will teach us assume as 0 or 1. Alright, so the next step is you write down the value, and then we do the analysis. We get, like for example, 1 here is supposed to hold. Alright, we get 0. Evaluate the Q from the truth table here. So we know 1 will get whole. 1 0 we get set clear. 1 we have whole again, and then 0 1 we get 1, and so on. And then after you write down the value, you draw the Q. This is the Q for the timing diagram. So how about NOR latch? So NOR latch also consists of gate, but from NOR gate. Also have S and C, and we also have Q and Q bar. But the difference is Q is here and Q bar is at the top. Compared to the non-latch, Q is at the top and Q bar at the bottom one. Alright, so this is the truth table for NOR latch. The difference between the NOR latch and non-latch is, you can see here, over here, and here, and also both of this one. So NOR latch is active high input. So we can sure that when we put 0 0, so the output will remain unchanged. If the Q previous is 0 1, the Q after also get 0 1. If SC is 0 1, so means that we activate the clear. So we get 0 as the Q and 1 as the Q bar. If we get put the input is S10, we get 1 as the output. And if we give the input SC11, you will get Q is 0 0. Both of Q and Q bar are 0. So this one is invalid because both are same value, because it is impossible because Q and Q bar should be inverted. Alright, so this is the truth table for NOR latch. So 0 0 is whole and 1 1 is invalid. If 0 1 will be clear the output and 1 0 is set the output. So we call this NOR latch as the active high input. So this is the symbol for the NOR latch. So as it is active high input, so there's no bubble at the input, right? So this is the example of the timing diagram. So if SC is 0 0, we know that okay, so this one is usually initially 0. So 1 0 it is set, 0 0 is whole, it will hold the previous output. 0 1 is 0, 0 0 is whole from the previous output. The previous output is 0, so it will hold the previous input output from the previous input. So this one also whole. 1 0 is set, 1 0 is also set, 0 0 whole, 0 0 is whole again, and 0 1 will be clearing the Q, and 0 0 will hold. So the same example and the same step. Firstly, you need to draw the vertical line at every input transition. So assume the initial Q is 0. So write down the value for each of the S and C, and then you need to evaluate the Q based on the truth table of NOR latch. So for example, like here 0 1 will get clear, 0 0 is whole, 1 0 is 1, and so on. And then you need to draw the waveform. You will get the waveform like this. Alright, so this is the same one, but this is the another example of timing diagram of NOR gate latch. Right? Okay, so this is the logic symbol for NOR. Alright. So this is another example. So if there's no bubble, means that this is NOR gate. So means that 0, 0 is whole and 1, 1 is invalid. Alright, another type of latch is D-latch. And we also call it as transparent latch, as it is copies input D to its output Q. And this is the circuit of the latch, and this one using NAND gate. To build the D-latch, we just put the inverter over here, and this one using NOR gate, also we just put the inverter and we get a D-latch. So the operation of D-latch is like this one. If D is 0, then the next output will be following the input of D. Like this one 1, the output also 1. So this is the logic symbol for D-latch. It has 1 input and 2 output Q and Q bar. Alright. So this is the summarize of latch. We have NAND latch, we have NOR latch, and we also have D-latch. So this is the logic circuit for each of the latch. So example, I will show you in different video. Alright. So for gated latch, so the difference between gated latch and latch is, gated mean they have control of gate enable signal. We have another additional signal which we call it as gate enable. If the input enables is 0, let's say we have E. So if E is 0, then the input for latch is disabled. Means that the latch will hold the previous value. If E equal to 1, so latch can change state based on the input. So E also can be symbol as E, G, or C. So there's two types of latch. We have SR latch and we also have D latch. So gated SR latch, so we have the additional enable over here. You can see. And we also can see there's no bubble as S and in R. So means that this is SR latch from NOR. So means that we following the truth table of NOR latch, NOR gate latch. So means that when 0, 0, there's no change, or we call it as whole. And if it is 1, 1, it is invalid. You can see here what happened if C or enable is 1, it will functioning as latch, but if it is 0, Q will be holding the previous input. Right, like this one. If C is 0, there's no change from the previous output. So this is the logic circuit for gated SR latch. There's additional here, additional input to the logic circuit. Alright, for example, like this one, the gated SR latch, we have additional of C here. So in this case, we need to draw the vertical line for each of the enable active. So means that latch will be active when C equal to 1 here. And it will change the output based on the SC over here along the E equal to 1. This one 0, 0, 0, 1, 1, 1. So you can see here, assume the initial Q is 0, so it will only change at Q when C equal to 1. So when C equal to 1, here it will become, okay, so this one 1, 1, actually it is invalid. Alright, alright, and then here 1, 0, But you can see here, S here are here. So 0, 1 means that it is clear. 0, 0 will hold. This one will hold. And this one 0, 1, 1, 0, sorry, it will set. This one 1, 1 is invalid. Another one is gated D-latch. So it will act as the D-latch, but with the control gate here enabled. So if enable is 0, Q will be remain whole. If 1, 1, it will following the D input. So for example, like this one, E is equal to 1. So it will copy all the input from here. You can see it just like transparent or copying the input from D. When enable is 0, it will be holding the previous from here. And when this is 1, it will be following the here. Alright. So for example, like this one, you need to draw the vertical line also, but for until enable to enable, when enable equal to 1. So it will be transparent from D, this one transparent from D, and the rest will be holding like this one. The previous one, this one will be continue like this, and this one continuing from here, hold. So the one, the previous one is 1, so it will become like this. Okay, means that this one holding, hold or same as this one. This one also same as this one. So that's all for latch and gated latch.